We're exploring the segment relationships in circles today. And the first theorem that we need to talk about is the segments of Chords theorem. The segment of Chords theorem says that when you have two chords that intersect inside the circle, they're going to break down into two separate segments. Each of those chords will have two segments that are made. And the neat thing about them is DF, in this case, this guy, times this guy will be equal to this part times this part. So on one segment, one part times the other is equal to the other segment's part times the other. Okay? You break your chord in portions, in two portions. One portion of that chord times the other part of it is equal to one portion of the other chord times the other one. Okay? Nothing to write down. It's all on your paper, on your notes paper. But let's put it to action. So here's our first example. And we are told that NQ is x plus 1 and NP is x plus 4. And then BN is 1 and the distance between N and A is x plus 6. So based on what we just saw, what's my equation going to say? X times x plus 6 will be equal to x plus 1 times x plus 4. Okay? Everybody have that? Now we're going to multiply, right? And solve. Multiply and simplify. So what is x times x plus 6? What is x times x plus 6? X squared plus 6x. So that's just distributive property. And we've got a FOIL on the other side. So first times first is what, Brandon? Very good. Outsides gets you 4x. Insides 1x. And lasts 1 times 4 is, yep. So we got some like terms that we're going to combine. Okay. On the right hand side we'll have an x squared plus a total of 5x plus 4. And here's the good news, we have an x squared on each side. Explain again. Why haven't we had to FOIL them out or and square things or? So are you talking about the segment relationships or the angle relationships? Okay. I don't know. I think they're just ready for you to review FOIL and review factoring, preparing you for Algebra 2. So up until now, you may not have had, they may have felt you didn't have enough, enough algebra practice to be ready for this, on top of the geometry and all the theorems and so forth. Okay? So this is more like Algebra 1 that you were used to, right? We're kind of transitioning you back into that mode so that you're ready for Algebra 2. Sure you do. All right, so the good news is x squareds are on both sides, right? So if I subtract an x squared from both sides, they go away. Yep, so 6x is 5x plus 4. Take the 5x away, and x is 4. Are we finished? No, why not? Unfortunately, no. We got to plug it in. Good. So when we plug 4 in, we'll have a 4 plus 1, a 4 plus 6, and a 4 plus 4. Okay? 4 plus 1 is 5. So NQ is 5. 4 plus 4 is 8. So 5 and 8 together get me a total of 13. PQ is 13. Okay? And then 4 plus 10 will be AB, or the distance between A and B, which is 14. Okay, so don't stop. Always check your directions to see if they're asking you to find X or to actually plug it back in. Okay? All right, one more example of this type. Now we want to find X again. Okay? So again, they're meeting inside. They're intersecting inside. So the part of one of the chords times the other part equals the first part of the second chord times the other segment. Okay? So, William, can you give me an equation for this one? X squared plus 5x, right? You're working one ahead of me because you're distributing it all the way, right? X times both of these. Good. Is going to be equal to what? Not 4 plus 6, but 4 times 6. Yep. Part times part equals part times part. So 4 times 6. So we've got 24 over here. Now what do we have to do? Can't just take square root of them because we've got a 5x there. It's quadratic now. So we've got to get everybody to the same side. So x squared plus 5x minus 24 is 0. And then we ask ourselves, what are factors of 24 that subtract to get 5? 8 and 3. Okay? It would be 8 and 3. Could have been 6 and 2, or 12 and 6 and 4, or 12 and 2, or it could have been 24 and 1. But you immediately recognized 8 and 3 are what we're looking for. Okay? So, 2 sets of parentheses. 8 and 3. What do my signs need to be? Positive 8, so we get a positive 5x when we subtract off our 3x. Does that make sense to everyone? That's the outsides and the insides. First times first is x squared. Outsides is a negative 3x. Insides a positive 8x for a positive 5x as a net result. And last times last is a negative 24. Okay? Liz, what makes this first parentheses equal to 0? What does x have to be? What makes the first parentheses equal to 0? Negative 8. And Jen, what makes the second parentheses equal to 0? Good. Now, you only get to do this in geometry. You don't get to do this in algebra 2. We get to decide which ones we want to use here. Ones that actually make sense in geometry. What do I mean by that? I like 3. Why do I like 3? It's 3 and 8, right? That makes sense for segments. What about negative 8? It doesn't make sense to have a negative 8 for a side length, does it? Or a chord length, or a segment length. So we can exclude the one that does not make sense in geometry. Not necessarily the smallest. -8 is smaller than 3. So we want only the positive answers on these. Okay? So 3 is our answer. Okay? We can't have a negative distance. All right. Next example. Yep. This is not hard. Okay? When you intersect them inside the circle, part times part equals part times part. Okay? The only thing that we have to do now is also talk about what happens when they intersect outside the circle. Okay? So when they intersect outside the circle, we have two things that can occur. We can either have a tangent and a secant that have the same external point. We could have two tangents that have the same external point, or we could have two secants that have the same external point. And they can all behave the same way. Okay? We have a theorem, the tangent segment and secant segment theorem, that says that the external segment times the whole segment, the whole secant, is equal to the tangent times itself. Okay? So the way I remember it is I say the part that's outside times the whole equals the part that's outside times the whole. And on a tangent, the outside part is the whole part. Okay? That outside segment is the whole segment, the whole tangent segment. So it says that PQ, the distance between P and Q, times the distance between P and R, the whole segment, equals the tangent squared, PS squared. Cassidy, put it away or it's mine for the day. Keep it away, please. Okay, here we go. We want to find the distance between W and X. Okay, the outside times the whole. How much is the whole portion of this? You just add it. Yep, 27. Okay, so outside times the whole, 12 times 27, it's going to be a big number, equals what? X squared. X times x. The outside times the outside, or all of the tangent. So x squared. Okay, so if this is x squared, if you're quick on your calculator, what's 12 times 27 is 324. Anybody know that perfect square off the top of their head? 18. It would be plus or minus 18, but we don't think about the negative 18. Doesn't make sense for us. Okay? And that's it. X is 18. Because there's more to it, because we're having to factor. Yep. Okay? Everybody good with this one? Okay? All right, last example. Now we have two secants. Okay? Two secants. So we have a portion that's outside the whole one, a portion that's outside in the whole. Okay? So we're wanting to take outside times whole equals outside times whole again. Okay? So here we go. Thank you. Okay? So how is this one going to set up? Almost. This is definitely 12, right? So 3 times 12 I agree with, which will be 36, equals 4. 4 is on the outside. Good. This whole distance is how much? 4 plus x. And if you want to call it x plus 4, that's okay. Okay. So 4 times 4 is plus 4x. Make sure you distribute that 4 to both. So 20 equals 4x, and x is 5. They didn't ask us for a measure beyond that, so we're finished. Okay? This is it. So assignment is there. Use your time, get it done in class, and I will come back and talk about yesterday's assignment too, if you have questions on those.